Today we'll be doing derivatives of inverse trig functions, and in this video we'll be looking at the derivative of inverse tangent. So there's two formulas that are usually involved. This is my go-to formula, but this one on the right is the more common formula. The formula goes as such. With regards to inverse tangent, whatever in the u component, if you take the derivative of the u component, you will put that on the numerator, and then the bottom will just be 1 plus the u component squared. That's my go-to formula. That's what's easier for me because I get to separate the function into components. It's easier for me to just plug the information. This is the more common one. If you want to use this, go right ahead. It doesn't make a difference. This is what I'm comfortable with. I'll prove this formula in the end of the video. Alright, let's start off with an example. So we want to find out what is the derivative of inverse tangent x to the fourth. So going back to the formula, what's the first thing we want to do? We want to get our u component, right? Our u component is x to the fourth. Awesome. Next up, we're just going to take the derivative of it. Once we take the derivative of it, we get what? 4x to the third. So we have our u component, and we have our u prime component. What are we going to do? Just simply plug and chug. And depending on how it looks, you do some algebraic manipulation, and then you get the derivative of your answer. You get the answer, which is the derivative of whatever inverse tangent you have. So we plug and chug, and we get this. The numerator is u prime, 4x to the third, and the denominator is 1 plus u squared. In our case, it's 1 plus x to the fourth squared. Depending on your professor, this could be your answer, but I think most professors are going to want you to simplify it because this doesn't actually look good. So you take x to the fourth and you square it, and you get this as your final answer, which is just 4x to the third plus 4x to the third divided by 1 plus x to the eighth. And that is the final answer of our problem. Now, let's talk about proving this formula. All right, so let's prove that the inverse tangent of x can be solved by using 1 divided by 1 plus x squared. First up, we want to make it easier somehow. Like our goal is to set everything equal to x. So we're going to set tangent. We're going to take tangent on both sides. This cancels out, and then we have a tangent over here, right? What's the next step? We want to find the derivative of y, so we're going to take the derivative of both sides with respect to x. If we take derivative with respect to x, that's going to make the derivative of x 1. And the derivative of tangent of y is going to be secant squared y. And because we're taking derivatives with respect to x, the y will also be included, and we'll get y prime. Then, because we're solving for y, we're just going to set everything equal to y prime, and we'll get 1 divided by secant squared. So how does this formula relate to this? I'll show you how on the next slide. You have to make a right triangle, right? And the right triangle is supposed to illustrate the relationship between x equals tangent of y. And if you see clearly, these would be the components of tangent of y. Y is your angle, x your opposite, and 1 is your adjacent. Pythagorean theorem, we get our hypotenuse as square root of 1 plus x squared. So how does this relate with 1 divided by secant squared? By this. So 1 divided by secant squared essentially is just cosine squared. And cosine is what? Cosine is adjacent over hypotenuse. So if we look at it, the adjacent side is 1, and the hypotenuse is 1 plus x squared, right? And we're trying to find cosine squared of y. So how are we going to do this? We put our cosine, the method of cosine, 1 divided by, it's our adjacent, this is our hypotenuse. We put it in, and we include the squared. So now it's 1 divided by square root of 1 plus x squared. And if we square this, we will get 1 divided by 1 plus x squared, because the squared is going to cancel the square root. And that's how you prove it. That's how you prove that the derivative of inverse tangent of x can be solved using 1 divided by 1 plus x squared.